Hey there and welcome back. In this video we're going to continue our endeavor to solve Wordle with APL, and in particular we're going to implement this CL function. So this small CL function, what it does is it takes a guess and a score and a list of words, and it's going to filter that list of words. And in particular it's going to remove all the words in that list that do not contain the correct letters in the correct positions. So, for example, if we have a guess and a score, the CL function, what it's going to do is it's going to take a list of words and it's going to remove all the words that do not abide by this score. So all the words that do not start with SWI. That's what the CL function will do. So let's check. Do I have? Yes, I still have my matrix of words, I think. Yep, so the first 10 words are in here. Alright, so how do we implement this CL function? How can we do this? Well, the first thing we need to do is we actually need to check which positions we care about. So we need to take the score and compare it with a 2. And this gives me the positions where we have 2's. So these are the columns that I'm going to care about. So if I take the P and I compress the guess, these are the letters that I want. And if I take the P and I compress the words, now I need to use the compress first. Sorry, the compress last. If I take the words, now these are the first 3 words of each letter. Sorry, of each. These are the first 3 letters of each word. Right. Now let's call this the subdata that I'm working with, or rather let's call the subdata just some of the words. So I can use compress to check the first 3 letters. Now how do I compare these against the letters SWI? How can I do this? Well, I can try to do it directly and see what happens. So let's see, the P compress of sub, so P compress of sub equals SWI. So obviously this doesn't work. And why is that? Because on the left we have a matrix and on the right we have a vector. But it's almost as if we wanted to treat each of the rows of this matrix as a vector itself. So what we really want to do is do the equals, but on arrays of rank 1. So we want to do equals on arrays of rank 1. And if we press enter now, this works because the rank operator is going to take that equals and it's going to apply it between all the vectors in this matrix, which really means let's take all the rows here and do that equals with all the vectors in here. But there's only one vector here, so we take this as a unit. So we compare the SWI with the first row, with the second row, with the third row, with the fourth row, etc. Now this is not very informative because there's no sort of match here. So let's actually compare it with, I don't know, AAL. Alright, so now we see there's a couple of matches. This is a full match and there's a couple of matches here. Now after we do this, we need to make sure that on that row every single thing must be a 1, because if there's a 0 somewhere it means that we failed. So after we do this comparison, we need to do an AND reduction across the rows. And after we do an AND reduction, we can take the original words and we can compress them. So this is the only word that survived. If we take a look at the words, this is the only word that survived because it's the only one that starts with AAL. So this is essentially the code that we need to write. We can go ahead and take this over here. So what goes where? Alpha is the guess and the secret, so let's split them up. And now what we do is, it's basically just this. So we do the comparison here, but instead of sub we have all of the words, right? Now what is P? P is the Boolean vector that allowed me to select these letters here. So what we're going to do is we have the guess here, but we want to compress it by the places where the score is equal to 2. And this is what P is. So we can assign P over there. Now we filter, and in the end we compress. So if we fix this, we can see, we can check if this already works. So the guess was, it doesn't really matter. Let's see, AALII, and let's pretend that the score really was 22200. And now, why do I have enclosing parentheses here? These are not needed. And then we do CL on sub. And this is the only word that survives. In fact, if I give it all of the words, it's the only one that survives because this is very specific. We had, what was it? We had Swiss, right? Swiss with these 3 letters. We have Swift, Swigs, Swill, Swims, Swine, Swing, etc. So this is what the CL function does. Now, before concluding, I actually want to show you something else. So let's take a look at CL. So CL is right here. I want to show you a better way of doing this comparison. So let's see. Fine, let's work with the sub again. So I have the sub here, and I want the first 3 columns, and I want to compare them in some way with AAL. Now what we can do is instead of what do you call it? Instead of using the rank and then the reduce, we can fuse those two together with an inner product. And the inner product, what we're going to do is, for each row here, we first compare it with AAL, and then we do the AND. Jesus Christ, we do the AND operation. So this is what we want to do. This is exactly the same thing. And we fuse the rank and the reduce into a single operation. Now the inner product can look funky at first, so do take your time to make sure you understand what's happening. And then I'll see you in the next video where we're going to tackle, what is it? So the filter function, CL is done. So I'll see you in the next video where we're going to tackle the IL function. And as a spoiler, go ahead and try to implement the IL function with a similar strategy. So actually I forgot to change CL because I think this is much nicer to use the inner product here. So it's the AND inner product with equals. So go ahead and try to implement the function IL and make sure to use a strategy similar to this one. So I'll see you in a bit. Bye.